Okay, here's the review for the test tomorrow over the logarithms. I've highlighted the ones I'm going to do. In the camera it looks like they're kind of hard to see, but you should have this paper already. First section, we're simply going to write these in logarithmic form. Here is the little conversion if you want to write it down for tomorrow. Y equals log base A of x goes to x equals a to the y. That way you can go from exponential to logarithm or logarithm to exponential, and all this on the right side can also be on the left side. So on the board I also have written log base A of x is equal to y, and a to the y is equal to x. I just switched the sides. Either way works. What's equal to one thing is equal to the same thing. Okay, number 3 right here. So we're going to take our values here. Here's my exponential over here, so I'm just going to copy off this one right over here. And I see 16 to the 1/5. My base is 16. A is my 15, so that what goes on the log. Log base 16. And then the x is what's equal to. Log base 16 of 64 is equal to, and this x over, this y over here is the exponent on the exponential, 1.5. That's what we're looking for right there. Number 8, same idea, but we're going backwards. Logs over here on the left side, so we're going to go ahead and use this one again. The base is x. We're going to raise it to the y, what's equal to over here, and that's going to be equal to 12, what's in the log. Next, we're going to do number 10. 10 is a graph. We're going to write the inverse, and then we are going to graph the two functions. So first thing I want to do is I'm going to go ahead and I want to graph this. I'm going to graph that in blue. I'm going to use the calculator. Just a quick refresher on how we graph in the calculator. So we're going to go to y equals. I'm going to clear it off, and I'm going to plug that in. 0.5 to the x power, and I'm going to go to the table. If I go to the table, I find points to graph. Okay, here we go. So if I come -3, 8, that's the first point left side I can fit on here. Anything before -3, like 16, -4, 16, doesn't fit on my graph. So how am I going to graph that? So -3, 8, 1, 2, 3, 8, there's 1 point. -2, 1, 2, 4, 1, 2, 3, 4. -1, 2, 0, 1, and for 1 it's 1/2. Let's go down a little bit. 1/2, 1/4, 1/8, 1/16, and it just gets smaller and smaller and smaller. So what this one looks like is a curve like that. This right here, this line that's getting closer and closer to, this is the asymptote. This asymptote is y equals 0. Just a quick reminder on that one. So that is my original function. Now what I'm going to do is I'm going to find the inverse. The inverse is when I take this and switch the x and y and solve for y. So if I make f of x my y, then I switch them. So x is equal to 1/2 to the y power. Now since my y is in the exponent, I just simply use my rules like I did up here. Here is my side of the exponent. My base is 1/2, so this is going to be log base 1/2 of x is equal to y once we switch everything out and use these rules right here, or this guide. So there we go. To graph that one, what I'm going to do is the same thing. Plug it in the calculator. Clear that off. Log base 1/2, you can go to either alpha window or math all the way down to A. You can get log base right there. So down here we can put 1/2 or 0.5, and then we're going to put X in there like that. And look at the table. Why do I see these errors over here? The graph does not go over here. That's why you get errors on the negative side. Probably means there's some sort of asymptote that it ends on. So our first point we can actually graph is 1, 0. That's that point right there. 1, 0. 2, -1. 2, -1. 3, negative about 1.5 or so. Then 4, -2. Let's see if there's any more. Alright, 8, -3. So look, I could graph those points in there. And these points, there's an asymptote here, and it looks like the asymptote is going to be 0. We'll talk about that later in the equation too. So this is going to come just like that. Just like that. So that's this one right here. And as a refresher, there is an axis of symmetry right down like this. And if you look at the green and blue lines, you'll see the green and blue lines reflect. Green line going close to this axis reflects over, blue line going close to here. Green line going through here reflects over here, and there's a blue line going over there. Everything's reflected on there. The last thing we're going to do, domain and range of my inverse. This is a logarithm, which means there's going to be a... Oh, first of all, let's talk about this asymptote. There's an asymptote here at x equals 0. That's this asymptote here for the log. Exponential has a horizontal asymptote here at y equals 0. The log has a vertical one at x equals 0. Now domain and range this one. Domain, it stops here. If you can look in the calculator, there is nothing to the left of 0, or 0 in this case. So it goes close to 0 and goes all the way, keeps going forever and ever and ever and ever to infinity. And because infinity we can't ever touch, leave it open there. And since it won't ever actually touch 0, we leave it open as well. My range for these are all real numbers. Alright, let's get down to the bottom. We're going to simplify and solve these. We're going to go ahead and simplify and solve these. So the first one here, if I look at it, I see a log. First thing we need to do is get my log by itself. I look at this one, my log appears to be by itself. Here's my base, here's what's inside the log, that's what it's equal to. So again, I'm going to use my rules up here, my little guide, and I'm going to convert it. So there's my base. My base is x plus 4. My exponent is going to be 2, and that's going to equal to 144. Again, we're just copying those. To get rid of this exponent up here, I have to do the opposite. The opposite of this is the square root. Take square of that, take square of that. The square root cancels with that 2. I'm left with x plus 4. Square root of 144 is 12. Guys, subtract that out. Minus 4, x is equal to 8. There's that one. Next one, we're going to do this other one over here, and we're going to leave it in logarithm form. We're going to leave it in logarithm form. So here we go. We're going to take this, there's my base, log base 25 of 144 is equal to 2x plus 1. Leaving it in logarithm form makes this real simple. All I have to do is get rid of this 2 and the 1. I get rid of the 1 first, that's a plus or minus. Then I worry about the multiplication. So I subtract 1, subtract 1. These are not like terms, so I'm going to leave it. Log base 25 of 144 minus 1 equals 2x. Now I got to get rid of this 2. Divide by 2, divide by 2. These 2's will cancel, and I'll be left with x on this side. Then over here, log base 25 of 144 minus 1 over 2. That is my answer, just like that. That is log form. If I wanted to get a decimal answer, I would just have to plug this in the calculator. Of course, please use alpha y equals and the little log base function. Press enter, and I'll tell you exactly what x is. Alright, next page. This top part up here is actually very good when you do all 4 of these. 1, 2, 3, 4. 4 of these in line with each other. You really get a good idea of where the asymptotes are and how they affect domain and range. But I'm not going to spend the time to go through all 4 of these with you. It'd be better if you did it yourself anyway. So the first thing we're going to do is the domain and range for this. Log function. I'm going to put these in the calculator just to get you an idea of what they look like. So this is log base 2 of x plus 2. And we're just going to graph that real quick so see what it looks like. Here we go. This is what it looks like. This, even though you can't tell, is actually going to an asymptote right here at -2. If you want to look at the table, you can look at the table and get an idea of it. You can see that the domain ends over there because of those errors. So the range for these log functions, are always going to be all real numbers. My domain is actually going to start at the asymptote. What is my asymptote here? Log functions have vertical asymptotes. If there is no movement left or right, it's an asymptote at x equals 0. Since this is moved 2 to the left, my asymptote is x equals -2. Which means my domain is going to start at -2. If this was reflected across the y-axis, it would end at -2. You gotta remember that too. It's another reason we can just graph things to look at it a little better. And it's going to go all the way out to infinity. Can't touch infinity, can't touch your asymptote, so we leave this curved braces. Now we have to find the inverse. To find the inverse, we're just going to look at the opposite things that happen here. Inverse is going to be an exponential function. My exponential function is going to have a base of 2, and it's going to be to the x. This horizontal change is going to turn to a vertical change. This went to the left, so that means that my exponential one will go down the same amount. My range will become my domain from earlier, -2 to infinity, and my domain will become, my range will become my domain in this problem. Asymptote will now be a y. So everything is just kind of switched. What was x is now y. What was x is now y. What was y is now x. What was a horizontal change is now a vertical change. Move to the left, move down. Cross here, cross there, switch the x and the y. That's what the inverse does. And again, if you want to graph this, I always like to graph things to see what they look like when I'm done or while I'm doing it. 2 to the x minus 2, and if I look at the graph, there's that asymptote of y equals -2, and you can definitely see that my range, -2 to infinity, my domain is all real numbers coming from way over here, going to the right and up forever, and there's again that asymptote y equals -2. Okay, on this page we're going to skip, well, Again, I would do all these. It gives you a good idea of what these look like. It's the same base the whole way through. Just kind of move left and right, up and down a little bit. This one's actually a good problem. It takes a while to do it though. You're just going to plot these points. I'm going to fill these points out for you. You can just switch them over. -1, 1/3, 0, 1, 1, 3, 2, 9. Those are simply these points right here. You just switch the x and the y for the inverse and graph that. And there's going to be an asymptote here, and it's going to go like this. Just good practice graphing there. 19. There are 2 major word problems on your test tomorrow. Here's an example of one. Seismologists use the Richter scale to express the energy or magnitude of an earthquake. The Richter magnitude of an earthquake, M, is related to the energy released in ergs, whatever that is, shown by the formula here. In 1989, an earthquake in the San Francisco-Oakland area registered a magnitude of 6.9 on the Richter scale. Find the energy. So it gives you the equation. All you have to do is fill in any values they also give you. So this is the magnitude. Magnitude is big M. So I go 6.9 is equal to 2/3 log, and then we have E over 10 to the 11.8. Okay. Now what I'm going to do is I have to get this log by itself. To get this log by itself, I'm going to divide by 2/3. You could have also multiplied by 3/2, whichever way is better for you. 6.9 divided by 2/3, we're going to go ahead and say that is 10.35. These cancel, so I'm left with log E over 10 to the 11.8. Now I have to convert this to an exponent. Again, we're using the same little conversions as we did up here that I've written on top in blue. Here is my base. If there's nothing there, we automatically just know that it's a 10. So I have 10, and I pull this from over here to the 10.35, and that's equal to E over 10 to the 11.8. Now I got to get rid of this because I want my E. The only thing stopping is this 10 to the 11.8 over here. So I'll multiply it by 10 to 11.8. Multiply this 10 to the 11.8. These cancel. This is same base. Exponents means I add them. That is 10 to the 22.15. And that's going to equal 1.413. When you put this in the calculator, times 10 to the 22. That is the ergs, or whatever, that was released in that earthquake. Alright, next page. We have graphing logarithmic function. Describe how the graph is transformed. Parent function, find the asymptote and domain and range. Okay, so first things first, let's go ahead and graph this. My favorite way to graph, make it easy for me. I plug it in the calculator, so that's a log. So math, go down to A. Base there. Oh, I could have just used the regular log. Actually, let's do that. So you can use the log down here. Log of x plus 3. And we're going to graph it. Can't graph off a graph though, so that's what it should look like. Let's look at the table. Looks like there's some sort of asymptote around -3. Alright, let's start graphing these points, see what they look like. Alright, negative 2, 0, negative 2, 0, negative 1.3, about a half at 0, a little over a half at 1, 2 a little bit more, 3 a little bit more, about 3/4, 4 is up there, 5 is even closer, 6 is closer yet, 7 we actually hit 1, and then we're a little above the line, just a little bit above the line, just a little bit above the line like that. And this curve, remember, if I look at this, there's an asymptote at x equals negative 3. Inside here, left and right movement, logs have vertical asymptotes. So there is a vertical asymptote at x equals negative 3. 1, 2, 3. There's a vertical asymptote right there. So this is going to come, even though you can't see it on here, it just kind of ends there at negative 2. It's going to come just like this and come straight down and hug that line, getting closer and closer and closer, but never touching. So that's what that one should look like. Let's go ahead and fill these values out. Description, well, we said it was shifted left 3. My asymptote we talked about, x equals minus 3. My domain, we know it ended at 3, so we use that negative 3 for my asymptote. Take it all the way out to infinity, and it's curve braces because it can't touch the asymptote or infinity. And my range for all these log functions is all real numbers. Wonderful. The other two, the only thing I'm going to tell you is they are reflected, so they might be a little bit different. Like this, across the x-axis. Alright, 23, we're going to do one of these on 23. Solve using your calculator. We're not going to use the calculator. If you wanted to use the calculator, you can put this in y1, this in y2, and see what they meet. I'd rather you be able to solve this the right way by hand. So by hand, let's go ahead and do this. A, we have, let's go ahead and translate this into a exponential equation. Can't figure out what this is until we get it out of the log. So my base is 2, my exponent is 5, and this is going to be equal to x plus 4. This right here, 2 to the 5th, that is not 2 times 5, that is not 10. So we have 2 to the 5th, just like this, press enter, that's going to get you 32. So 2 to the 5th, 32 is equal to x plus 4, and then for this x plus 4, we got to get rid of the 4, minus 4, that cancels, 32 minus 4 is 28, equals x. Other ones done the exact same way. Okay, next one. We have number 24. We're transforming this log like it says and then telling us domain and range. If we do this one, we're going to get some sort of log function. Base isn't changing. Alright, so let's see our changes. Vertically stretched by a factor of 4. Vertically outside, 4 like that. Reflected across the x. This is the x-axis. Up and down like this, up and down, vertical, outside. So reflected across the x, need the negative in front. And translated to the right. Left and right go inside, so we're going to do something inside the log. To the right would be negative 5. There we go, we've written it down. Domain. Domain's going to start at my asymptote. So let's check the asymptote first. My asymptote is if it moves left, right. Remember, logs have a vertical asymptote. This one is shifted to the right 5, which means my asymptote is at x equals 5. Which also means my domain starts at 5 and goes to infinity. Now, if this was reflected left and right across the y-axis, this would be negative infinity 5. Range, these all real numbers. And then this is the third last one we're going to do. This is the last word problem we're going to mess with today. This is another magnitude type problem. Now we're dealing with brightness. We get all that information I'm not going to read right now. And basically, here's our formula, and here's the information we got to plug into it. It tells you what all these little letters mean. So find the distance. So this is what we're finding, that distance there. And then its magnitude, its apparent magnitude. See, apparent magnitude is little m. So that is 1.14 minus, and I get to the big M, which is 0.7. That is my absolute magnitude. And absolute magnitude is m right there. So that is 0.7 equals 5 log d over 10. Alright, just like that. To get rid of this 5, we have to divide both sides by 5. In your calculator, you can quickly do this. 1.14 minus 0.7 is going to be 0.44. Divide that by 5. You're going to get 0.088 is equal to log of d over 10. Now that you have a log, logs by itself, you are going to go ahead and convert this to an exponential. Base there is 10 to the 0.088, like that, is equal to d over 10. I have to get rid of this 10 now. To get rid of that, multiply it by 10, multiply it by 10. Those cancel. D is equal to, same basis here, when I multiply these, I'm going to add those exponents. Same base, add those up. You get 10 to the 1.088. That is D equals 12.25. That is the distance in whatever it is here. And to the 100th is 2 places. Alright, last 2. There are several of these on the test. Again, you have to find the inverses. To find the inverse, you have to switch the x and the y's. So let's start off by switching the x and the y's. This is y equals log base 2 of x plus 4. So let's go with x equals log base 2 of y plus 4. All I did was switch the x and the y's right now. My log's by itself, so let's go ahead and make it exponential. 2 to the x equals y plus 4. I need to get rid of that 4, minus 4, minus 4. Wait, this is an x, sorry. 2 to the x. So I have those canceling to get me y is equal to 2 to the x minus 4. It says up here to check these both ways. We're just going to do it one way. So we are going to pull the original one here, log base 2, but instead of x, I'm going to write this, which is 2 to the x minus 4. She's not here. Wait, never mind, she's out. And this is going to be plus 4 there, like that. Alright, last one. We can be done with this. Last one, so we did a log here. This is an exponential, so we're going to end up with a logarithm down here. Okay, so we have to switch the x and the y, so I get x is equal to 5 to the y plus 3. Go through those in parentheses, and then that is plus 2. Before I can do anything, I got to get this exponential part by itself. I'm going to subtract 2 on both sides. I get x minus 2 is equal to 5 to the y plus 3. Now my exponential is by itself, so I can go ahead and switch it to a log. My log is going to have a base of 5. Inside the log is going to be x minus 2. And on the other side of the equal sign I have y plus 3. Now the only thing I have to get rid of is the 3. So minus 3 like that. I have y is equal to log base 5 of x minus 2 minus 3. I'm going to take that. That's the answer I'm looking for, and we're going to plug it into the original function. My original function was 5 to the, and then there's an x there, so my x is going to be log base 5 of x, is it minus 2? Minus 2 minus 3, and then we're going to go back to this, plus 3 plus 2. And those are all the ones I am doing on this video. Please finish this tomorrow for your extra points.